Chapter 4.1, Inverse Functions. We know the definition of a function. Now we're going to expand that to one-to-one functions. A one-to-one function is a function, which means every x value corresponds to exactly one value. But to be one-to-one, every y value must also correspond to exactly one x value. Remember, our vertical line test determines if a graph is the graph of a function. And now the horizontal line test is going to determine if the function is a one-to-one function. If we do not have a graph, we can sketch the graph, or we can either show that it's one-to-one by showing that f of a equals f of b, implies a must equal b, or show it's not one-to-one by finding two x values that correspond to the same y value. So if I'm trying to determine if this function is one-to-one, the easiest way to do it is realize, oh, that's just the function of a line. It's a linear function, goes through -8 down here with a positive slope of 2, so it's something like this. And again, we know it's a function because it crosses that, vertical line test. Now we know it's a one-to-one function because it also crosses the horizontal line test. So yes, this one is a function. This one, the graph of that one may be pretty hard to determine. It's not just the square root of 36 minus x, but I might notice, hey, I have this x squared in here. If I do let x equal -1, then I have y equals the square root of 36 minus -1 squared, or the square root of 36 minus 1, which is the square root of 35, then that is exactly the same thing I get if I just let x equal +1. So, no, it's not a function, because if x equals -1, y is square root of 35. If x equals +1, y is square root of 35. Not a one-to-one function. If a function is one-to-one, however, it will have an inverse. Okay? If it is not one-to-one, it will not have an inverse. Inverse functions undo each other. For example, f of x equals x cubed and g of x equals cube root of x are inverse functions. They undo each other. If I plug one into the other, so if I take the cube root of x and cube it, everything gets undone and I'm left with an x. Or if I put x cubed into my other function, again, everything gets undone and I'm just left with an x. That means these are inverse functions. So to determine if two functions are inverses of each other, plug them into each other. If all operations are undone and leave a single x, then they are inverse functions. In other words, if f of g of x equals x and g of f of x equals x, then f and g are inverses. So let's use the definition of inverses to determine if f of x equals 3x plus 9 and g of x equals 1/3 x minus 3 are inverses. So that says, okay, What do I get when I do f of g? I'm going to start with f. So I have 3, but instead of x, I'm going to put g, 1/3 x minus 3. Now finish my f plus 9. Here's f of g. Well, getting rid of the parentheses, 3 times 1/3 is 1x. 3 times -3. So far, looking good. Let's see what we get when we do g of f. This time I'm going to start with g, but everywhere there's an x, I'm going to put the function f, and then finish my function g, distributing to get rid of parentheses. 1/3 of 3 is 1, 1/3 of 9 is 3, minus 3 equals x. Yes, these functions are inverses. If at either step I get something other than plain positive 1x, they are not inverses. If f and g are inverses, the domain of f is the same as the range of g. The range of f is the domain of g. Also, if f contains the point AB, then g contains the point BA. They're inverses. You can think of them as opposites. Everything's just in the opposite position. Whoops. To find the inverse of a one-to-one function, here are our steps. Don't forget, first of all, make sure that it's one-to-one. If it's not one-to-one and it's asking you to find the inverse, your answer is there is no inverse, right? It is not one-to-one. So first of all, I'm going to replace the f of x with y. Then I'm going to trade places with the x and y. Not algebraically correctly, just literally trade places with the x and y. Solve for y. So I need to add 2 to both sides. Okay, just trying to solve for y. So let's get rid of that negative, right? And now cube root both sides. Trying to get the y all by itself. So finally I have y equals the cube root of negative x minus 2. Now this is the step most people forget, and it's really important to remember to replace the y with our f inverse notation. This notation is read f inverse. Has nothing to do with a negative exponent, right? It's f inverse. So once I get it solved for y, I have found the inverse. I haven't found y. Here's y, right? Those aren't the same thing. So I can't have y equals this, and then in the exact same problem, say it equals something else. It's very important to change that notation back to f inverse. The process is the same every single time. All right, make sure it's one-to-one. Replace f of x with y. Trade places with x and y. Solve for y. Replace y with your f inverse notation. Okay, let me know if you have questions.